First, I want to start by asking you to explain some of the work you've been doing with Global Building Modules, GBM.
Right.
And how you see it fitting into we hear a lot about modular construction, but there's a lot that needs to be fixed, and you think you might have some of the solutions for it, I hear.
I do. Starting in 2005, I began working with a startup company called Global Building Modules, or GBM. And we set out to find a solution to industrialize the building process on a global scale. Our key insight was that the problem of transportation is the key to, quote, cracking the code, unquote. That the conventional modular industry is built around the notion that the largest possible modules are the most economical. But as a result of that, they've limited their market to about a 200-mile radius, beyond which transportation becomes exorbitant. And not only that, when one is talking about building mid and high-rise buildings in a dense urban environment, these oversized modules are subject to heavy regulatory burdens, which limit the hours in which they can move through city streets, and also in some locations like New York require police escorts. What we've done at GBM is to base our module on the size and technical attributes of a shipping container, meaning that it's able to be transported using the intermodal transportation system. That's ships, trucks, trains, and can merge seamlessly into the automated freight handling system that goes along with the intermodal system. That opens up global markets. It costs about the equivalent of $12 a square foot to ship a module or a shipping container, depending on whether you're shipping clothing or consumer goods, or in our case, a little chunk of architecture. $12 a square foot, about halfway around the world.
What's that equivalent figure for these larger modules that are more common now, if you know?
Well, halfway around the world, I actually don't have that number
because
nobody does it.
Sure.
You know, it just doesn't pencil out.
So it's supposed to say it's substantially more cost effective.
Right. Not to mention all the problems once you get that module onto the back of a truck to move it to a job site.
Is the reason that they started as larger modules because the thinking was that's fewer parts to assemble and therefore most efficient?
That's the essence of it. I mean,
why doesn't that apply?
Sorry?
Why doesn't that apply? Because it seems like if you did have, lots of small pieces, that you'd be working with a lot of detail and you sort of lose some of the economy of scale of modular construction. Or no?
That, on the face of it, that's a true statement. But what we've discovered is that even though you have more seams to patch up in the field, more mate lines, as we call them, if you can truly systematize and create a set of standard parts, that can be done rapidly, and the economy and market power of being able to operate on a global scale is so far more important that isn't really the issue anymore.
So you mentioned shipping containers being part of this scheme, but I don't want people to get hung up on thinking that this is just shipping container architecture,
right,
because there has been plenty written about some of the challenges of that, and it's been called a fad and not necessarily applicable, appropriate for most environments in terms of insulation,
right,
residential uses, et cetera. So why shipping containers, and why is this so different?
All right, well, we're focused on transportation, not on the shipping container itself. Yeah, there have been a lot of really interesting and compelling projects done using the shipping container as an artifact. What we've done is stripped that container down to its essence, its volumetric dimensions, and the 8 corner nodes that enable it to integrate into the automated freight handling system. Starting with that, we then completely re-engineered the frame to be optimal for building construction. We have developed facade systems based on rain screen technology, which solve all of these problems of the metal can baking in the sunlight and freezing in the winter. We insulate outside of that metal shell and put a lightweight cladding system on it. And we've standardized all of the interconnections and even breaking that standard module down into a planning grid that allows us to standardize interior fit-out on a kit of parts basis. So there's a lot of flexibility in layouts. There's tremendous flexibility in choice of materials, choice of cladding systems, arrangement of fenestration, and massing. All of these things are able to be manipulated according to the architect's design concept.
When it comes to building tall with modular, there's been a lot of roadblocks. What are some of the main challenges of using modular construction to build tall, and how are you hoping to address that?
Right. We've been working with a really terrific structural engineer, Leslie Robertson and Associates, as the structural engineer who's been behind our technology. We think that one has to develop lateral load systems, which are become more and more important the taller you go, that are fully integrated into the module. And one of the mistakes that's been made has been to use a conventionally built braced frame system in conjunction with factory-made modules. And so you have a mismatch of tolerances. You have difficulty integrating and connecting in the field. By integrating the lateral load system within the module, you solve those problems.
So a lot of this is sort of generally speaking about making customizable design mass producible. That sort of seems on its face impossible, right? Contradictory. So how does your system square that circle?
Right. I like to think of the analogy of the iPhone. The iPhone is a device with a standard operating system that has spawned hundreds of thousands of apps, many of them niche apps that just do one very, sort of specific thing for a specific group of users. I think of our system, which we call the module a volumetric unit of construction, or VUC. The VUC is like the operating system. It's a standard chassis that can then receive myriad components, myriad secondary systems like sun shading systems or balconies. The interior can be varied depending on the kinds of finishes and fit out that you want. What we expect to do is to license third-party app developers who will be incentivized to develop all kinds of creative ways of customizing the VUC. And because we're operating on a global scale, those app developers will have an enormous market to sell into. And what we expect to happen is that there will be climactic variations in the apps that are developed, regional variations in the apps that are developed, maybe even cultural variations. What we envision actually is the flourishing of a new global vernacular built on social networking, the idea that this is a kind of collective project that grows and evolves over time, continually expanding and offering new possibilities.
How does your system prevent homogeneous design, homogenization of cities around the world?
By offering a backbone, a pre-engineered plug-and-play backbone that can then accept myriad variations of detail, of fit-out, of facade development, of climactic response, of materiality. And what I'm counting on is the creativity of the design community to accept this as an opportunity and run with it.
Any clients or applications at this point that you'd like to share for the system?
Well, FXFOWLE, the firm that I'm with, has been doing a series of studies for developers that are really deep, not only design studies, but also technical studies. So far, we haven't yet taken anything to built form, but GBM is now in discussions with a financial partner who also is in the real estate space, and we expect to close on a round of financing for GBM and see some projects get underway in 2016.